All right, good morning. So this is going to be the pre-lab video for experiment number 37, electrochemical puzzles. Now, electrochemical puzzles is going to be a little bit of a combination of you collecting data from a demonstration and me providing you guys data in the second set. Now, while there have been several videos where we can see the golden penny side of the experiment, there's not many where it does all of the data collection that we're looking for in our write-up. And so I'm going to provide you with that information. For the first part, for part one, we're going to watch this demonstration on corrosion put on by the Royal Society of Chemistry. Now, what we're doing is we're taking these 3 jars. In their case, they're going to do a total of 5. And they're going to look at when do things corrode or oxidize. Right? So when we're looking at corrosion, we're looking at the oxidation of a metal. And so they try one out with just iron and DI water. They do another one with iron and salt water. And they do one with iron and just normal tap water, oxygen. Right? Now, we're not going to be worried about these. We can still watch them, but these results are not going to be in our lab. But the part that we're going to be interested in is they're going to do one with iron and copper, and they're going to do another one with iron and zinc. Oh, not zinc. They're going to use it with magnesium. So right now, go ahead and look at your lab. And what I want you to do is I want you to replace this one, where it says copper and zinc, go ahead and X it on out. We're not going to do that one. And the one where it says zinc and iron, replace it so it's magnesium and iron. Now, when we do this, there's 2 things that we're going to look for. One is phenolphthalein, and the other one is a blue color from the potassium ferrocyanide. Now, phenolphthalein is an indication that there's hydroxide being made. And the reason why we care about whether hydroxide is being made is hydroxide is going to give us a sign whether our whether we have any reduction. The potassium ferrocyanide, this 2+, is going to let us know if we have any oxidation of the iron. So when we're looking at our Petri dishes, what we're looking for is if there is any pink, then we know hydroxide is present and reduction has occurred. We can also start to see about, well, if there's any blue, then we know that this is oxidation of the iron. Now, if we see one and not the other, then it gives us some information there as well. So let's say that we only see pink. We'd still know that reduction is occurring, but the oxidation must not be iron if it's only pink. If it was only blue, then we would have the reduction. Oh, I'm sorry, it should be reduction of that iron. I'm sorry, that is oxidation. If we only have the blue, that does mean that we have just the oxidation of the iron, but our reduction must be something else besides the hydroxide. Now the agar that we use is going to help us kind of slow down the ion movements. So we can track where they're localized. We can start to see where they're starting, where they're forming. So we're not going to do this middle section, this copper and zinc, the one without the iron. We're always going to use the iron. So we're going to do one with copper and iron, and then we're going to do one, and it will be magnesium and iron. But we can list those down. We can write those same observations. Now, this video that they have, it takes about 30 minutes. I recommend watching all the way through. It makes a lot more sense as you go through it. But the ones that you're looking for are basically the last two experiments that they do from their Petri dishes. You're looking for the ones where they start to wrap the metal around an iron nail, so that way you can see what happens. For part 2, it's something called the golden penny. Now, pennies are normally made out of copper. Now, they're not completely copper. They're just copper on the outside. Normally, it's like a zinc or a nickel in the middle, depending. I believe it's zinc, actually. And so what we're going to do is we're going to do a series of experiments where we're going to try to connect them with some zinc metal. And we're going to put them into a hydroxide solution. So we're going to connect them in several different ways. One of them is we will connect the copper to the zinc by a long wire. Another one, we might just take that copper wire and we might connect it to the outside of the container. We're also going to have one where the copper just sits on the zinc. And we'll have one where the copper just sits in the solution by itself. So all of these things are happening inside our hydroxide. And we're going to see what happens. Now, if our penny starts to change color, then it gives us an idea that there's electrochemistry going on, that we might be plating our metals down. So if our copper starts to turn silver, it means that there's zinc metal that's being plated onto the copper. If our copper stays looking the same, then we know that it hasn't changed at all. And then afterwards, we're going to add some heat to it. Because when you have zinc and copper, when you apply heat, you can make a combination of them or mixture. And it's called an alloy. And this one specifically is called brass. And that is what's going to give it this golden color. So in your next lab, so moving forward from here, part 1, you will get that information in your observations from the Royal Society of Chemistry video. For part 2, I'll be providing this data in the next lab. Right? So I'll draw out the pictures, we'll start to see our results, and that way we can collect all of that data that you need for it. There's also going to be a demonstration of it so you can see it in action.